Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about properties of set difference operation. In our last class, we clearly discussed about what set difference means. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, let's take first we will understand what set difference means. Let's take two sets A and B. A minus B means the element that belongs to A and does not belongs to B. In simplified way, from A, remove the elements that are common with B. Remaining elements we call it as A minus B. So A minus B, one of the property is equal to A intersection B complement. So we will derive this. Let's take x belongs to A minus B. Then we can write it as x belongs to A and x does not belongs to B. That is what B complement means. This can be written as x belongs to A and x belongs to B complement. So now we can write this as x belongs to A intersection B complement. So A minus B is A intersection B complement. Now we will show it in the Venn diagram form. This is B, this circle. B complement means remaining area, which this complete blue line area we call it as B complement. Means universal set minus B, we call it as B complement. So in this universal set U minus B complement, we are having A also. The common elements are not there in A. So A intersection B complement. A means this part of the A. See this is the entire A intersection. What is B complement? In B complement we don't have common elements of B and A. So A intersection B complement is only this part of the A. That is what A intersection B complement means, which is A minus B. So this is our first property. Coming to the second property, A minus A equal to phi. So remove common elements from A. What is common elements of A? Same elements. If A minus A, we are taking the same elements. So what are the common elements between A and A? All the elements. So A minus A is equal to phi. Similarly, A minus phi equal to A. So what are the common elements between A and phi? Nothing, no elements are there. So A minus phi equal to A. Coming to the next one, A minus B equal to B minus A. We can say that A minus B equal to B minus A only if A equal to B. Then only we can say that. Otherwise, in any other times it is not going to be A minus B equal to B minus A. Let's take an example. A, B, 1 to 5, 1 to 5, both are same. Then only A minus B. What are the common elements between A and B? All the elements. A minus B means phi. Similarly, B minus A means phi. This is the only situation where we can say that A minus B equal to B minus A. Similarly, the next property is A minus B equal to A. If so, A minus B, remove common elements in A. If there are common elements, then A minus B equal to A. This is not going to be happen if A intersection B is equal to phi. If A, B both are separate, there are no common elements, then A intersection B is equal to phi. Then A minus B means from A, remove the common elements. There are no common elements. What's remaining? A minus B is equal to A. Suppose if you take 8 as a common element in A minus B means 1 to 5. 8 is not there. 1 to 5 is not A. 1 to 5, 8 is A. So that's why A minus B equal to A if A intersection B is equal to phi. Similarly, the last one, A minus B is equal to phi if A subset of B means the complete A inside B, then A minus B equal to phi. A minus B equal to phi if A subset of B. See, A 1 to 5, B 1 to 5, 7. Remove the common elements in A. All the elements are common to B. If you remove all the elements from A, what's remain? It's 5. So these are the properties which we are going to use in our coming classes. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.